All right, so welcome everyone to HCI meetup number 4. It's our pleasure that Laetitia Bornes will give a talk today. The title, as you can see on the screen, is Exploring Systemic Design and Prospective Modeling to Facilitate the Sustainable Design of Interactive Systems. So it's a very good topic, an intersection between systematic thinking, systemic design probably on the engineering side, right? And the design of the interactive system. And for all of us here, we are interested in human-computer interaction. So I think this topic is very interesting. So a little brief introduction of our speaker. Laetitia Bornes is actually right now currently a PhD student at the engineering schools in aviation and aeronautics from the University of Toulouse in France. And so today we will learn about what is system thinking and systemic design and the model that our speaker has created in order to actually bring system thinking into the design world. So here's to you, Laetitia.
Perfect. Thank you very much, Tipaya. Thank you for inviting me. I'm really grateful to be able to present some of my work today. And thank you very much to all the attendees. So this was, this was perfectly introduced. Just a bit of context, but it's what Tipaya just said. So my thesis is between two labs, one at Aviation School of ENAC, and the lab is working about human-computer interaction, and the other one is at Supaero, so Aeronautics Engineering School, and the lab topic is systems engineering. And the motivation of this thesis is that until recently in sustainable HCI or sustainable ICT, the research efforts mainly focused on life cycle optimization of a system, energy efficiency, and persuasive design that is presenting, let's say, indicators to the users so that they can understand and diminish their consumption, their energy consumption. So this began around 2007, and around 2014, some researchers began to recognize the fact that sustainability is more systemic and complex than just trying to lower some specific parameters such as energy efficiency, and that persuasive design had limited effects. So there's a bunch of literature saying that we need more method and tools to capture the dynamic and systemic aspect of sustainability. It scales time frames and diversity of stakeholders. And what the community, the HCI community needs is really concrete and actionable methods and tools, because since 2014, there are a lot of papers about the fact that we need something more systemic, giving some insights and concepts, but not really actionable, practical method and tool for the practitioners. So one of the causes of the systemic aspect of sustainability, a reason why sustainability can't be treated only by acting on the parameters of a system, on its consumption, is the rebound effect. So the rebound effect is when improving the energy efficiency of a system, let's say car engines, it enables drivers or users to save money or time, and therefore to use more this system, so to drive more. For instance, I save money on the consumption of my car, so I will be able to drive a lot more often or longer, and maybe at a systemic level, people will live further from their work because they can allow them to take more this transportation, and this will in fact lead to an overall increase in fuel consumption. So this diagram, I will detail it a bit in more detail later, but what you can see is positive green line arrows and negative blue arrows. So positive arrows say that when all the other things are equal, if A increases, then B increases. And the other way around, with the other things equal, if A decreases, then B decreases. And the negative arrows are the opposite. So when A increases, B decreases, and when A decreases, B increases. So this one describes a loop. When the energy efficiency is higher, then the cost per kilometer is lower. When the cost per kilometer is lower, then the distance traveled per day per user is higher, and then the higher emissions, and then the higher investment on efficiency, because we see the problem, and then the higher the efficiency of the engine. So this is a reinforcing loop. Everything is evolving to be higher and higher or lower and lower. Okay, my English is not perfect, so if you want me to reformulate or really do not hesitate to ask. So this leads us to thinking of interactive systems within systems of systems. So the idea is to think about not only the interactive systems, so the computerized systems whose behavior adapts to the user actions, but also to think about the interaction with the whole socio-technical systems that they are interacting with. So the human and technical organizations that operate these systems. So this example is with agricultural robotics. When I design an agricultural robot, I should think about the whole agriculture sector and also the social systems, so the broader layers of society that benefit from or are affected by these systems. That can be the users, the people demonstrating because some things are wrong with the agricultural sector and so on. I have a much more relevant example to HCI community, that is a platform for selling second-hand clothes that exists in Europe. I don't think it exists in Asia. So this one is called Vinted, but maybe you have something similar here. So this platform allow people to put some old clothes for sale, and allow some people to buy these items. So that seems circular, that seems nice because it's using longer an item, but in fact it has some rebound effects. So you can divide rebound effect into different categories. So the direct effects would be, in that case, the carbon emissions due to the transportation of the clothes. We could speak also about the carbon emissions due to the data centers, to the application itself. But you have other effects. For instance, it's well documented about this app. In fact, some sellers use the money they earn from their sale to buy even more new clothes. So they just buy new clothes, they wear it twice or 3 times, and then they put it on the app. They sell it for almost the same price so that they can earn this money and buy more new clothes. So that's not really the sustainable effect we were looking at. And also buyers, if they can buy items for more affordable items, they will be able to buy more items. And also eco-conscious buyers may feel less guilty about buying second-hand clothes. So in average, they will buy 2.4 more clothes when it's second-hand than if it was new clothes. So these are second order effects. These are rebound effects. And this is not exhaustive, but we have also higher order effects that are more systemic, that are more at the level of the society. And here, for instance, we observe a drop in donations to charities because people, they just change their practices. They don't have anymore the reflex of giving the clothes they are not using anymore. So as now they can sell it and earn money, they really change their practices, and it's like it's systemic. So you see a big problem among charities now, and a change in the mentalities. People don't think of charities as much as before. So all of it just brings the fact that the impact of an interactive system, here the Vinted app, is not limited to the physical impact of this system. So not only the consumption, the carbon emissions linked to the data centers, for example, and it's also highlight the fact that the design of an interactive system can influence these societal and systemic effects. So the question I try to address in my PhD is how can we represent and anticipate the impact of a project at the scale of a socio-technical ecosystem. And for this, I rely on systemic design, which is a new branch of research at the crossroads of design thinking and systems thinking. So first, what is design thinking? I think you are used to it, but yeah, it's a nonlinear and iterative process that designers use to understand users, challenge assumptions, and redefine problems, and so on. It's really useful to tackle problems that are ill-defined, and the process is described depending on the sources with 4, 5, 6 different stages, but mainly we can summarize it with a user research, with documentation, surveys, interviews, observations, and other techniques to collect data. Then you have a synthesis and of the user research and the defining the objectives through can be personas, user journey, experience map, service blueprints, and so on. You have the ideation and design stage with ideation techniques, participative design techniques, and so on. And you have the prototyping and testing stage, where you collect feedback and analyze it. And it's obviously not a linear process as mentioned before, but I mean, I guess that these stages ring you a bell. Systems thinking on the other side is a way of making a sense of the complexity of the world by looking at it in terms of wholes and relationships, rather than by splitting it into its parts. So that's really opposed to the reductionist and Cartesian approach. And in fact, it's not really opposed, it's complementary to it. So when we speak about splitting a problem down into its parts, for instance, we can think of really specialized disciplines. Physics is split into many types of physics, and that's allowed humans to invent a lot of and discover a lot of things. But splitting everything down makes us lose the complexity of the world. So systems thinking is opposed to this reductionist approach. But the important thing to learn is that both approaches are complementary. And systems thinking is useful to tackle complex situations. So we don't speak of problems in systems thinking, but situations. And it tries to enable systems change. So yeah, the whole idea of systems thinking is to present things as systems with a structure of different elements, and instead of looking at each element separately, we really focus on the dynamics and interaction between elements at different scales. That's why we speak of systems of systems. We really look at the big picture, that is the system itself, and that has properties that couldn't be understood when looking only at the parts of the structure of the system. So these are emerging properties. For instance, one example Akov gives is that a car, if you just split a car into its elements, you will see wheels, you will see engine, but you won't, with these different parts separate, you won't have the main purpose of a car, that is driving someone from a point to another one. So the driving property is an emerging property of the whole car. So systems thinking comes from, at the beginning, the general system theory, mostly discovered or created by Ludwig von Bertalanffy. So in the 60s, this is when people from different disciplines, biology, cybernetics, and other fields, understood that they could describe what they were doing or the subject of their studies with the same framework that was the same for all the different disciplines. So it's an interdisciplinary practice that describes a cell of the human body, a thermostat, a company, or a society with the same framework. And at the beginning, it was really formal or even mathematical framework to describe it. And then, so I'm really simplifying it because, but then I will give you all the references if you want to go further. We can see systems thinking as a bunch of 5 or 6 trends of research, but the most simple way of describing it is opposing hard system thinking and soft system thinking. Hard system thinking has emerged first, and then soft system thinking is like system thinking of second order. So hard system thinking is the really scientific side of systems thinking. Here you can see a stock and flow representation of a thermostat and of the economic capital. So this is to just illustrate the fact that the same formal description can be used for really different topics. I won't go into details in this formalism, but you have stocks, flows, and variables, and you have sort of loops that can be compared to the loops the reinforcing loop I was describing at the beginning for the rebound effect. So these are representation really often used in systems dynamics, that is among hard system thinking. And this is from Thinking in Systems of Dunela Methods, which is really an important researcher in systems thinking. And on the right side, you have the representation of the simulation of a model, which is from The Limit to Growth, which is a book published in the 70s, where they try to model all the dynamics of the world. So they try to see the interaction between the food per capita, the non-renewable resources, the population, the capital, and to see that if we have less resources, then we will use more capital to create more food. If the population evolves in this way, then so they described all this interaction into a model, a computer model, with the same approach as this representation, but with code. And they described several scenarios representing how the world could evolve, and the outputs, the outcomes of this simulation is that as our resources are limited, we cannot have an economic growth that is unlimited. But this is a huge topic. It's just to show that this is really what we think of when we speak about hard system thinking and systems dynamics. And soft systems thinking is more about management, about psychology, about a way of seeing the world and a way of seeing all the interactions between different things of different levels. So this first illustration is from the systems thinker, and it's called the iceberg model. It's just saying that you can see about the world, you can see some events, some pattern, some structure, and some mental models. And this is an example about management in a company, for instance. So one event would be a worker is late on Tuesday. A pattern or a trend would be this worker or several workers are late every Tuesday. So the structure of it would be, so the structure and the cause of it would be no flex time, and the mental models behind it would be maybe there is a lack of trust for employees. So it's just a framework of thinking to deal with management, with organizations, and so on. And this is an example from Czechland of soft system methodology. And I won't go into too much detail, but it's about saying that in any case, people have mental models of what is going on into the real world, but they can have different mental models. So his methodology relies on bringing these mental models to being explicit. so that people can really work together. Okay. And the last thing about systems thinking, which is, I think, really important, is also available in Thinking in Systems of Donella Meadows, and is the leverage points she's describing. So I just put 6 of it, but in fact, you have 12 leverage points she identified, and she also said that we should keep on studying how we can intervene in a system. So she's saying that when it comes to a system, it's faster to change, to intervene on constants or parameters or delay and feedback loops, and the more difficult and slower to put in practice, but the more powerful is to change the system rules, objective, and the paradigm. So if I refer to the Vinted application example, moving constants or parameters would be, for instance, to use a more efficient transportation system. For instance, if I deliver the clothes with a more green system, it will change the CO2 per kilometer, but it won't change the system itself. But the paradigm in the case of Vinted application would be to change the way people relate to clothing. Really, maybe it won't be useful anymore to have a selling platform, because people would be more keen to repair their own clothes, or to sew their own clothes. So that is a really good also framework to think about how we can intervene in a system. And then if I come back to systemic design, which is at the crossroad of design thinking and systems thinking, I think really it's the next step for design, at least in HCI. First, we were focused on the product level. So in the 80s, for instance, I would define my objectives and evaluate if my objectives are met at the level of the system parameters. Now we are more focusing on the user experience. So I will define my objective in terms of user experience, and I will evaluate if my objectives are met at the level of the user with user testing. And for me, systemic design is the next step, is to say, okay, I define my objectives at the level of the system, and I will evaluate it at the level of the system as well. So systemic design is combining system thinking and design thinking also in the process. This is the description of the process by the Systemic Design Toolkit, with some stages more related to design thinking and other stages more related to systems thinking. So here we have framing the system. It's defining what is our system. Here it's the system of clothing in Europe, for instance. Listening to the system uses quite the same techniques as the user research in human-centered design. So you would have observations, interviews, and so on, but with a lot of different stakeholders, more than just the users. Understanding the system is, synthesis of what we understood in listening to the system, defining the desired system, exploring. I'm sorry, because this is the other way around. It's systems thinking is on the top, and design thinking is on the bottom. So defining the desired future, exploring the possibility space, designing an intervention, and fostering the transition. So the whole thing is really close to the 4 steps we described earlier, but at the level of the system. And there are a lot of different organizations, researchers, and practitioners giving some toolkits or advice about systemic design. This one is maybe the most popular, and it gives some templates for each steps that are different from the templates we could use in human-centered design, such as user journey, for instance. Yeah, the difference between systemic design and interaction design is that for the moment, from what I saw, systemic designers, they really analyze and operate at the levels 3 and 4 of design. So Jones and Buchanan, they describe design with 4 levels. The first level is traditional design. Second level is product and service design. The third level is organizational transformation design. So at the level of company, at the level of, for instance, the health structure of a country, and the design 4.0 is at the level of the social transformation. So within this framework, systemic design is analyzing the objective and the effects they want at the level of design 4, and they are also intervening at the level of design 4 or 3, that is by designing awareness raising, regulations, incentives. So they are really working for non-governmental organization or for governmental agencies. So they don't design systems such as interactive systems. And we in interaction design may want to have impact at the level of design 4, so at the level of society, but our level of intervention is at the level of design 2, by designing individual cars or social networks or public rental bikes or and so on, and or an application for selling second-hand clothes. So if we come back to this application, what I try to focus on in my thesis is the step 3 and 5 about understanding the system and exploring the possibility space, because these are where the current user-centered methods and tools and techniques have to be adapted, because we can't represent the synthesis of what we understood of a system in the shape of an experience map or a user journey, because it's not just one user and one system, but a whole socio-technical or social system. And the stage of exploring the possibility space is also really interesting here, because we cannot just prototype and test as we do in user-centered design when it comes to a whole system, such as the whole system of clothing in France. So what systemic designers use often to describe what they understood from a system in a formal way are causal loop diagrams. So here you have a causal loop diagram of what I understood of the Vinted example. you have the same formalism as earlier with the green and the blue arrows. And what's really interesting with this type of representation is that you can describe causal mechanisms. So the more money is earned from sale in the platform, the more money will be reinvested in new clothes, and the more clothes will be produced, fast fashion clothes, and this will have an impact on the clothes market, but also the more additional carbon emissions you have, and clothing related waste. It also allows to describe feedback loops. So for instance, the fact that the number of clothes we give to association is lowered, it makes the budget for charities decrease, and if their budget decrease, their popularity will decrease because they will have no money for advertisement or for making more events. So that is a reinforcing loop that describes the beginning of the end of charities, for instance. And what's really also interesting in causal loop diagrams is that you can mix really variables of really different nature and scales. For instance, the emotional connections, the emotional connection of someone with second-hand clothes he just bought, to the number of times these clothes will be resold, to the additional carbon emissions. So you will have qualitative and quantitative data that can be related and that are really, in fact, related and interacting in real world. So this type of representation is really interesting, and it can bring design ideas. For instance, for the Vinted application, we could think of a feature to limit the distance traveled by the clothes. So, for instance, I can filter only clothes that are really close to the buyer. We could also incite users to donate some type of clothes if they are, for instance, if they have been on the platform for 2 weeks and they are not sold. We could allow the seller to send these clothes to charities for free, or we could also think of virtual currency so that the money earned on the platform would stay in the platform. So these are just examples of different design ideas, but in fact, what I think is that this representation brings maybe some ideas, but does not allow for seeing combining the ideas, seeing the priorities. So these causal loop diagrams, they do not allow to represent quantities or orders of magnitude. Is the distance traveled by clothes really more important than the number of clothes that are the quantity of money reinvested in new clothes, for instance? We cannot represent dynamics nor delays, and that's really important in systems dynamics. And in fact, it's not a representation of the current state of the system and its possible evolution. It's just a representation of the causal structure of a system. If I move this, then it moves this, to understand, to have to align our vision of what is going on. But it's not saying how many clothes are sold each year, how is what is the average distance traveled by the clothes, and so on. So that's why in my PhD, I'm trying to bring a quali-quantitative modeling framework to support decision making and design decisions. So the idea is to it's really aimed to designers and decision makers. And the idea is to enable the representation at different scales and timeframes, and to allow people, stakeholders, to build their own model and understanding of how a system works, so that they can communicate and iterate on their own model, and so that they are not captive of a research lab. It's for the explicability of the model, because you could have this modeling done by a lab, but it would be maybe longer, and also the designers or decision makers, they won't know exactly the limits of the model. They won't be able to make it evolve. So yeah, the idea is to enable to build a light model and to project scenarios with quantitative indicators, and to compare relatively these scenarios with these indicators. So the objective is not to predict the most probable future for second-hand clothing, but to being able to explore possible futures and to see different scenarios, and to yes, support decision making with it. So it's a prospective approach and not predictive approach. And as we see that the future is really uncertain, I think it's better to rely on human intuition, on experts' opinion, on qualitative survey, and also quantitative data to build this type of model, and to use it within a design process. So this is an example of a model of Vinted platform, sorry. So what I forgot to say is that I tried to model socio-technical dynamics with existing generic tools in systems dynamics, but it was really not usable for designers or decision makers. So I wanted to be able to propose a tool that is really specific to modeling interaction between a product or the service and the socio-technical system. So we developed a prototype within my team with Smala, which is an interactive language, and the calculations are in C++, and we can we can describe dynamics, quantify it, and run simulations and compare relatively different scenarios with this prototype. If needed, I can also show the real prototype later. Oh. And yes, so this is not only a tool. The tool is the tangible, concrete thing, so that we can use the quali-quantitative modeling framework in different case studies. And as this is really concrete, it's easier to have feedback from people. And the whole methodology is first to identify with the relevant stakeholders the variables of our system, and the variables that are of interest to us, for instance, carbon emissions and donations to charities and so on. Then identify the influences. So I use something close to the group model building, and try to quantify these influences. So for each arrow, we will try to think of a way to quantify it. Sometimes it's really simple. It can be just computed. For instance, the link between CO2 emissions and the distance traveled by the clothes. And sometimes we have to extract data from the platform itself, or to run a survey, or to have an expert opinion and to make some hypotheses. And then the idea is to, from the data collection methods, to iterate on the diagram and to model and compare scenarios so that we can make some decisions among time. So maybe lower decrease the distance of the clause the first year, and on the third year try to make the money on the platform virtual. And yeah. So yeah, I have 4 case studies. The first case study about an energy self-sufficient airport was an academic case study, and was to model, I don't present it today, but was to model with generic modeling tools. And the outcome was that it was not usable and understandable for designers or decision makers. The second case study is that of the Vinted platform. And I organized several workshops with designers, and the idea was to make the really quick version of the participative modeling methodology, and to collect their feedback on the utility, usability of this method. Right now I'm working on an electric train project in a rural area in southwest of France, which is a real world case study with policymakers, engineers, experts, companies, and citizens. And later on, I will have this agricultural robotics company case study. About the eco train project. So it's a carbon-free light train that would be operating on an existing railway line in southwest of France. So this area suffers from depopulation and aging. Companies have difficulty finding workers. There is little to no transportation services in this area. And so politics are thinking of putting a carbon-free light train. But what we are trying to see here is what could be the impact of the train, not only on the transportation of people and the access to health facilities and so on, but also the impact on the employment in the area, on the real estate, because if you make it more accessible, people can also move, buy a house there, and keep working on outside this area. So it can move a lot of things. Yeah. And in this project, we had several workshops with the political representatives. We conducted an exploratory observation on site, interviews with residents, quantitative survey among residents and workers. We made some focus group with enterprises and interviews, and we have to make some interviews with real estate agents. It's not the case for the moment. And we will also have a quantitative survey during the summer on tourism. And yeah, I won't detail this because it's the end, but our first workshop allowed us to make this diagram representing the different variables and interactions. The variables in purple are that are leverages that we can act on, and the green ones are the variables of interest, such as ground artificialization, carbon emission, and so on. We iterate on these with the second workshop and field observations. And then we try to identify how we could quantify each arrow. So that's through the quantitative survey I spoke about, the focus group with enterprises, and so on. And we just began to build a first really little version of a model, but it would probably be 10 times bigger than this example in the end. So yeah, that's it. Some takeaways, maybe we could email to you, or good books about systems thinking and systemic design. And I must say that there is a conference that is really useful called Relating Systems Thinking and Design that will take place in October the next time. And it's already open to registration, and I will conduct a workshop in this conference if you're interested. So thank you very much for listening, and I'm waiting for any question or feedback.
Thank you very much, Laetitia, for your interesting talk. Is there any questions from the audience? Feel free to ask. Yes. Oh. Feel free to ask any question. Okay. If not, maybe I can try the first question. In your model, you saying that you're trying to deal with. Oh, okay. Chat first. Go first.
Oh, you can also start with your question first. I don't mind.
Okay, sure. I'm curious about, well, because in your model you try to accommodate both qualitative and quantitative variables, but one of the example, after you draw a causal loop diagram and then you draw, like, you have a trend, right? You say your model can calculate trends, or like some not projections, but I see some graph. So did you mean you have to quantify like qualitative variables in to generate those graphs?
Yeah, that's a really good question. In fact, In fact, this is one of the results of trying to put it in practice, really. In fact, the model that will be in the modeling tool will really represent only quantifiable variables. So something about the level of, for instance, the emotional connection to close won't be in the quantified model. But we can embody these things with quantified variables. So, for instance, here I have the whole picture of the eco-train project. I won't be able to quantify all of it because there are some links that are really difficult to quantify, or that are also, a bit qualitative. But it's important that people who are using the model, the quantified model, participate to the building of a more quali-quantitative model before. And then we just embody a part of it in a quantified model. And I don't have the answer for every situation because I'm still working on it. But for some qualitative things, it would be more, dividing into different models or scenarios. For instance, I will make a diagram in the quantitative tool. If we can bring a stronger emotional connection to close, we can expect this type of quantitative things and scenarios. If not, maybe I will do another scenario and say, okay, this is the optimistic scenario, the pessimistic scenario regarding the emotional connection to close, for instance. So yes, when we speak about the leverages as described by Meadows, the paradigm leverage we won't quantify it. But we can say that if we can shift the paradigm, we could expect these kind of quantifications, because in fact the carbon emissions we will have anyway. But okay, if we can shift the paradigm, then we can imagine it would be this type of diagram and scenarios. And sometimes it could be embodied in an indicator, for instance, for the agricultural robotics. The company I work with, they said, okay, the quality of life of farmers depends on the hours they have to work each day and their exposure to chemicals. This is difficult. I think I would prefer to just keep the quantified thing and say, okay, the exposure to chemicals will be decreased. But speaking of quality of life, with just an indicator that is quantified, it's a bit difficult. I think it's misleading.
I see. Thank you for your answer. Thank you very much. Okay, so Chad, please.
Yeah, thanks a lot for your talk. I think that your talk is great at educating us about system thinking. And like, I can see that the challenge of this talk is you need to tell people first about like what is system thinking before you can get into like the exciting work that you are doing. And I think this strength of the talk might have been came at a cost of the clarity of the problem statement of your interactive systems. I think that like so far that I can grasp from your talk, and I also read your doctoral consortium paper, like what I got is that the problem statement is that existing system for dual system modelings are difficult to use for designers, and you want to fix that. But it is unclear to me, like, why is it difficult for designer? Which aspect that it is difficult? Is it like too many features, too many quantification, too many things that expert in system thinking can use easily, but designers who are not familiar cannot use? Is it vocabulary, or is it not? Does it not support specific formalization that will be useful for designer for prospect modeling? Could you maybe shed light on this part a little bit? What is like, why is the existing tool, why exactly are they not suitable for designers or for your target user groups?
Yeah, sure. In fact, yes, just first to introduce the fact that I had to build my own prototype for this is not really, I mean, it's not the main topic of the thesis, the prototype. It's just an enabler to be able to explore modeling with designers and decision makers, because I couldn't find a tool that would be suitable for them. And why I couldn't find it? Yes, because system dynamics generic modeling tools are, and that's true, I didn't develop on that, it was my first case study, are really aimed at experts in systems dynamics, and they require coding, they require understanding the formalism I show at the beginning. It requires understanding a bit of physics and system dynamics in general, and that has not been re-evaluated since a while. So it's first really for a generic application, and not for really socio-technical product to interacting with socio-technical systems. So that requires coding. We can't have any easy pre-coded interactions between different variables, and what I wanted to say, sorry. And yeah, what I just observed is that, in fact, within the systemic designers community, nobody uses stock and flow diagrams. They all use causal loop diagrams. That's because when you show this to someone, it's really not easy to communicate. It's also really not dense. It's really to describe a whole system, it would require a whole wall, because it's really not it's not a dense representation. And when you show sorry, this type of representation, everybody is quickly at ease. It's not directly straightforward, because the positive and negative arrows, it's not that simple to catch, but it's really often used by systemic designers, and stock and flow diagrams are not. So it's really a formalism that is closer to how our brain interprets it, and not closer to how physics works, you know. And I saw in this lack of generic tools that are suitable an opportunity to say, okay, I will just try to keep as simple as possible, close to the causal loop diagram representation, but I will try to embed the quantification and the possibility of simulation, but with the strict minimum. And then through my case studies, I will see what specific blocks could be an enabler and could help to model without coding. So what are the specific functions I need to describe, for instance, you have the adoption of a product into a market. It's a curve that is like this, and you can already put it in the tool, and the user could just parameter the time they think it will last, and the intensity, and it's already they don't have to code, and it's already describing some dynamics of socio-technical systems.
All right, thank you very much. This is very helpful, and it is like much clearer. I mean, it's like the contribution of bringing tools that are designed only for experts to the broader audience. That is already a big contribution. And you also like add on top of that contribution by like providing the diagram types and components that are commonly used in socio-technical systems. So I think like these are valid, and I wish I have heard about this part in the presentation itself. Maybe this is like short feedback for your presentation for your like next time that you give a talk. Do we still have time for more questions, Tipaya, or are we running out of time? I have some more questions, but I would be gladly to yield the floor to other people.
I think we probably have time for one more question, the final question for the session. Okay, I guess it's chat, fire away your question.
Okay, all right. So this question will take a step back from your focus on your specific contribution of your thesis. But I would like to hear your thoughts about the role of designers in system thinking. What do you expect interaction designers to do? Because, for example, like in your example of the clothes vintage app, if the interaction designer is working in that company and the company already have the market plan that, okay, we will build a app for this purpose, even if the designer can do system thinking and they can come up with insights that, oh, this app will be harmful, designer cannot do anything, right? Because basically they are practically hired to do that job. So like, what do you expect to be the role of the designer, or who will need to participate in the systemic design in order for systemic design to work?
In fact, that's what we talked about in the designers workshop I organized with professional designers. What is the feasibility and how could it work in their companies? For the moment, I think like now, more and more designers are willing to work at strategy positions. So you could have a designer profile in a strategy positions in a company. But for this to work, so that's just to say, I think it's this approach has to be transversal from the different layers of the company, and the best scenario would be that a designer or a design-minded person would be at the strategic level, or somebody that is just a freelance for this specific topic. Today, this can work only with the companies that are willing to make change at the social level. So the agricultural robotics company I'm talking about is a mission-oriented company. Mission-oriented company that is opposed to a profit-oriented company. So, for instance, they have 4 specific goals that are more than just making profit, and that are about quality of life for farmers, carbon emissions, ecotoxicity, and biodiversity. So when the company is structured to have impact and not only to make profit, that is really difficult for a company in our economic system. But some companies already are structured that way. And then I hope that in the next years, it will be more and more mandatory to have such an approach. That's what I hope for.
Yeah, very, very optimistic future. And like, I hope that we reach that future, at least like partially in our society. Thank you very much for your answer.
Thank you.
Thank you very much for the questions, and the answer is really inspiring. So yeah, I think we kind of at the end of the talk now. So again, thanks all the audience, and especially thanks Laetitia for the talk. And hopefully not just we see each other here for this talk. Hopefully we can have some future collaboration or co-activities in the future. All right, so
thank you very much, everyone. Kopunka.
Merci beaucoup. Okay, then bye-bye then. So that's let's call it a night for today.
Bye.
Thank you.
Bye.
Bye-bye.
Au revoir,
Thank you very much.
Laetitia.
Thank you so much.